In the previous movie, we generated waves in our ocean using a texture-deformed primitive as an accelerator. In this movie, we'll create a more dramatic tidal wave, then explore different cache methods to avoid the performance hit during scene playback. Make sure to set the current project to the provided scene folder, then open the file Coastal Town Part 3 Start. We've already removed the wave simulation you created in the previous movie, thus reverting it to the still water simulation you ended up with in Part 1. Right now, our simulation is in equilibrium. In order to create an effect as dramatic as a tidal wave, we'll need to introduce a major influx of liquid very quickly. To do that, let's create a new emitter out of a polygon cube. Rename this cube Tsunami Emitter Geo. Translate it to the far end of the ocean container, and scale it to the size shown. Select it along with the Bifrost node, and go to Bifrost Add Emitter. Your simulation now has two emitters. The original Ocean Emitter Geo object emits our initial volume of water, while this new Tsunami Emitter Geo object emits the constant stream of liquid that can interact with the existing body of water. Go to the Tsunami Emitter's Shape tab and make sure to change the Bifrost Liquid Emission Physical Attributes Density value to 0.001 to match the ocean emitter. On top of generating more liquid, we also want Bifrost to use the new object as an accelerator. Select both the Tsunami Emitter and Bifrost node and go to Bifrost Add Accelerator. Go to the Tsunami Emitter's Shape tab. Under the Bifrost Acceleration Geometry Influence section, set direction to 100 since we want the accelerated tidal wave to head towards shore. Also increase direction magnitude to 5000 to generate some extreme force. Play the scene. This initial tidal wave is off to a good start. However, notice the wave vanishes before it can splash onto shore. This is because we created a kill plane in the previous movie to contain the ocean simulation as a performance precaution. Delete the kill plane closest to the shore. This will allow the water to pass into the town. However, in order for the wave to flow through the streets, we'll need to convert the street and building objects into colliders. Expand Town Group fully. Select all the objects in this group, except for Ocean Bed Geo, along with the Bifrost node. We provided a quick select set if needed. Go to Bifrost, Add Collider. Play the simulation again. As you'd expect, the tidal wave slams into the shore before flowing through the streets. However, notice over time that the deluge doesn't stop. A real tidal wave shouldn't persist like this, but rather subsides in intensity over time. Let's try ramping our effect up and down to better reflect this. Go to frame 24. Select the Tsunami Emitter and go to its Shape tab. Under the Bifrost Acceleration Geometry Influence section, set a key on direction magnitude. Scrub to frame 23. Decrease direction magnitude to 0 and set another key. This one frame transition will generate our initial wave. Now scrub to frame 36. Decrease direction magnitude back to 0 and set another key. This allows the deluge to peter out. You can increase the size of the tsunami emitter to generate even more liquid, resulting in a larger wave, or vary the range of frames over which a wave is generated and the run up to shore to affect its volume. We've included two different examples in the scene files provided, but we encourage you to experiment even further. When you're happy with your tidal wave and flood simulation, hide the tsunami emitter. By default, Bifrost is set up to balance performance and fidelity. You can increase the accuracy of your simulation at any time by decreasing the Bifrost liquid container node's master voxel size attribute. A smaller voxel size allows you to greatly increase the base resolution. However, this also impacts the computation time of your simulation. By now, you may notice that generating scratch caches takes longer as our simulation becomes more complex. In addition to the scratch cache we've used so far, you can use a disk cache to optimize simulation playback. Unlike the scratch cache, which automatically regenerates every time you modify settings that affect the simulation, the disk cache should be used to store the final look of your liquid, since it stores files on disk per frame. This allows you to remove extraneous nodes such as the kill planes, emitters, accelerators, and so forth without breaking your simulation. Make sure you've turned on the particles display in the Bifrost Shape tab so you can see the simulation as it caches. Go to Bifrost Options. Turn off both Enable Background Processing and Enable Scratch Caching, so Maya doesn't use the scratch cache while creating a disk cache. Then select the Bifrost node and go to Bifrost, Compute and Cache to Disk to cache your simulation. Maya begins generating the cache. Once finished, it automatically applies it to the caching section of the Bifrost Liquid Container tab. At this point, you can streamline your scene a bit by removing the collider and kill plane objects. Scrub through your simulation to see that the liquid reacts appropriately, even with the scratch cache disabled and the collision object on. Using this disk cache, you can even generate a Bifrost mesh as we showed in part 1. In preparation for the final render, you can increase the mesh's fidelity in the Bifrost Shape tab's Bifrost Meshing section by adjusting the droplet reveal factor and resolution factor attributes. The higher you set these values, the more fine resolution details like splashes and distortions are retained, though at the cost of performance. To offset these calculations and optimize our scene even further, we can create an alembic cache of the generated liquid mesh itself, which would not only allow us to strip the Bifrost simulation out of the scene entirely, but also reduces the computational stress on Maya at render time. Select the Bifrost node and go to Pipeline Cache, Alembic Cache, Export Selection to Alembic. Turn on the Write Color Sets option to ensure that all the texture data is cached properly. Then export this cache as Tsunami Alembic. Once the cache is generated, you can import it as a new object by going to Pipeline Cache, Alembic Cache, Import Alembic. Then apply the existing Bifrost material shader to the cache geometry. Now you can delete the remaining nodes related to the Bifrost simulation. If you play the scene, the tsunami plays much faster. From here you can batch render this animation without incurring a hefty dynamics performance overhead.